Hello and welcome to the review lesson for Unit 4 Graphing Quadratics in our Grade 10 Academic Math class. So this review, I realized, is actually very much it could be treated like a lesson. So I'm going to look at components of it anyway that might help you see how all the stuff we've learned in this unit sort of comes together. So we're talking about quadratic relations. Quadratics, when graphed, create a parabola, which is that U shape that we have. We've learned three different forms of a quadratic: vertex form, factored form, and standard form. Now there is one thing that is common to all three forms, and that is the A value out front. So what you'll see here is I've highlighted it here in vertex form, sitting right out front, here in factored form, sitting right out front, and here in standard form, sitting right out front. So what does the A value tell you about the parabola that's being modeled? It tells you the direction of opening, so whether our parabola opens up or opens down. If our A value is positive, our parabola opens up. If our A value is negative, our parabola opens down. We call that a vertical reflection across the x-axis. It also tells us the plot pattern, in that having an A value larger than 1 is called a vertical expansion by a factor of A, and it impacts our plot pattern by multiplying 1, 4, 9, which are our output values for going out 1, out 2, and out 3 from our vertex, respectively. If our A value is a proper fraction, so between 0 and 1, we call that a vertical compression by a factor of A. So that's common to all three forms, which is helpful. Vertex form has an additional piece of information, and that is the vertex, and that is the H and K values. Now I do want to point out that the H value, because this equation comes with a negative in it, it is the opposite of how it appears in the brackets. So for example, if it was x minus 2, in those brackets there, it would actually be a positive 2 that is our H value. It's the opposite of how it appears. So how do we go about graphing from vertex form? Well, it's pretty straightforward actually. You plot the vertex on your coordinate plane, and then you apply the plot pattern according to however much A is going to impact that, and then you do all your labeling and call it a day. That's vertex form. So you'll notice here, and I've sort of made this drawing, so maybe I'll just get that fully on the screen right now. This might be a good moment to pause and put down the sketch that I've put here on the left. It sort of ties all three forms together, and I did some color coding and stuff like that. So maybe hit a pause, copy that down, and then come on back and I'll continue talking. Okay, you've copied it. You see the vertex is down here, the H and K values of our vertex brought to us by vertex form. Next is factored form. So what does factored form have by way of information other than the A value? Well, it has the S and T values, the values found inside the brackets. They correspond to the x-intercepts or zeros. And again, you can see them here, S and T. Those are our x-intercepts. How do we go about graphing from factored form? Well, we need to get the vertex, so what I would do is we would plot our two x-intercepts, and then we would find our vertex by first finding H, by taking the S and T values and dividing it by 2, and then find the corresponding Y value by substituting x equals H back into the equation. Once you've got the vertex, you can apply the plot pattern, put in all your labels, and that's graphing in factored form. Last but not least, we have standard form. Standard form, outside of the A value, tells us the y-intercept. That is the C component hanging out there, the constant term at the end, and again you can see I've got the C value right here on the graph labeled. So how do we graph from standard form? Well, we can put the y-intercept on there. It's not particularly helpful. We need to go about getting the vertex, so there's two ways we can do that. The first is if you've been provided the axis of symmetry, x equals h, you can just substitute into the equation to find k. That's one way. You can also make a table of values using points on either side of the axis of symmetry if you've been given that. Of course, if you haven't been given the axis of symmetry, you can go about completing the square to find the vertex. After that, you complete your sketch by applying your plot pattern, and then put in all your labels and call it a day. So that's really the big thing that we've been doing in this unit, is learning about the different forms of a quadratic and then how to go about graphing them. So the next thing you would need to do is the worksheet. So I'm going to go through just a few of these for you. The correct answers, of course, are all up on our class website. Let's start with this one right here. This one, because it's it's pretty straightforward, we're going to start by graphing here. So the first thing you're going to want to do is identify which form of a quadratic this is. And I think it's important to note that this is vertex form. And I recognize this because it has brackets, or I guess a bracket, squared. That's how I can identify something in vertex form. So what does vertex form give us? It gives us the vertex. So the vertex in this case is going to be, again, the opposite of how it appears in the bracket. So x minus 3 is actually x minus positive 3, so that will be a 3, 2 will be my vertex. So let's get that bad boy on the graph. So we have 3, 2. There's our vertex. I'm going to dot in my axis of symmetry here. Dot, 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 all the way through the vertex, top to bottom, and then labeled with the x component of the vertex, which in this case, x equals 3. And now we need to just apply our plot pattern. So let's look at our a value. Our a value here is invisible, kind of. It's +1 hanging out front. So if we're looking at our plot pattern of 1, 4, 9, going out 1 in either direction from the vertex, 2 in either direction from the vertex, or 3 in either direction from the vertex, we are going to amplify each of these by the a value, which fortunately doesn't change anything. We know that because our a value is positive, our parabola is going to open up. So let's continue with our sketching. From our vertex, we go out 1 and up 1, out 2 and up 4, and out 3 and up 9. It's 4, 5, 6, 7, 8, 9, right at the top there. All right, just squeezed on there. So now we are going to connect this with a curvy line. And let's get some arrows on there to show our graph is going to continue. And let's do some labeling. So we have the y-intercept to label, which is nice. That's going to be 0 and 11. We don't have any x-intercepts, so let's label our vertex. That's going to be 0.32, and let's label the equation itself. So that is y equals bracket x minus 3 all squared plus 2. So that's how we graph in vertex form. Let's look at some of the other forms. I'm going to kind of try to do one of each here, or at least look at some of the different ways this might work. So here we have y equals -x squared plus 6x. So what form of a quadratic is this? This is standard form. And standard form has no brackets. No brackets. So for us, we know this is standard form and it tells us the y-intercept. Now the y-intercept, also kind of invisible here, it is the constant value kind of hanging out here at the end. So we know that our y-intercept is going to be 0. So I'm going to put that on the graph right now, 0.00. Now standard form doesn't help us a whole lot because we don't know what the vertex is. We don't have any of that good stuff going on. But the instruction here, fortunately, is factor to graph. So what we're going to do is we are going to factor the quadratic that we have, and hopefully that'll give us some more information. Factoring it will turn it into factored form, and then from factored form we can get the x-intercepts and then work our way towards the vertex. So if I were going to factor this, y equals -x squared plus 6x, I'm going to be just looking for the greatest common factor. So the greatest common factor is -x. Negative because this leading term is negative. So when the leading term is negative, I'm going to factor out a negative value. So I factor out -x, and I'm left with then x minus 6. So I'm going to put these points on the graph. Fortunately, in factored form, we're given the x-intercepts. And I'm going to write this in a slightly different way. X plus 0 and x minus 6. Hopefully this will help you see that we are dealing with, I'm going to change up my color here, we're dealing with two distinct x-intercepts. One is 0, which is just sort of collapsed in on itself, and the other one is 6. So let's get 6 onto the graph. There's 6. Now, we can do some math in order to figure out what our axis of symmetry is, but we know that it's going to be halfway between these 2 points, which sits right here. So I'm going to just dot this axis of symmetry in all the way top to bottom, and that is going to be x equals 3. And now we can go about figuring out what the y component of our vertex is by substituting into the original equation. So I'm going to take my original equation, y equals negative x squared plus 6x, and I'm going to substitute in 3. So there's 3 squared plus 6 times 3. That's going to give us negative 9 plus 18, which means our a value, or rather our k value, is going to be 9. My vertex then is going to be 3 and 9. So let's pop that on the graph. 3, 9 is my vertex. Now looking at the plot pattern, my a value is negative 1. Now the negative just tells me my parabola is going to be opening down or reflected across the x-axis, so that works okay. The plot pattern is going to, with an a value of 1, just stay 1, 4, and 9, because we'd be multiplying this by 1, so all those results will be the same. So let's start graphing them. From our vertex, out 1 and down 1, out 2 and down 1, 2, 3, 4, and out 3 and down 4, 5, 6, 7, 8, and 9. And those line up to our x-intercepts, which is super convenient. So now let's sketch through our graph, making it as curvy as possible. Let's put some arrows on this guy, and let's start labeling points. So point 0, 0, one of our x-intercepts, point 6, 0, one of our x-intercepts, our vertex, 3, 9, and the equation y equals negative x squared plus 6x. And there is a second graphed example, this time from standard form that we factored to get x-intercepts and then went on to find our vertex. So again, don't have an extra page here, so I'm kind of just pushing it all around the perimeter of the graph, all my math. You're welcome to do these types of calculations on a separate page. So I'm going to come back and do just a couple more examples. So this is the end of part 1. We're getting pretty long. So we'll come back with a brief part 2, and then you can get into the review on your own.